Hello, this is Jerry Pendergrass. I'm doing a talk today on the CASL language specifically designed to interact with SAS Viya. My name is Jerry Pendergrass. I work at SAS Institute. I'm a distinguished software developer who had 30 years at SAS doing anything from Unix development to core development to working on the CAS team, working on the Viya server, and now I'm one of the primary developers for the CASL program. So what are we really talking about here? We've got a new language that is specifically designed for SAS. I want to really entice you to interact with it, understand it, and make it part of your team, make it part of your tools that you're going to use to access the CASL server. When I did this, I designed a program that was embeddable into many different locations. So currently we have 3 applications of this language. The first application is a proc. It is ProcCAS. It runs in SAS. It has become one of the most important tools that we have today in SAS to operate the SAS server. Almost all of our testing is done through ProcCAS. It has been a life-saving program that gives us so much functionality. We also have the SCCASL runCasl action. This allows you to take your program that you would normally run in SAS, but run it actually as an action in the server. This allows you to get closer to your data, and once you're in the server, you actually have a few extra special things you can do. But the code is identical from one place to the other. We actually don't know where you're running. It looks the same no matter which location you're running from. We also allow you to put an interface on top of that program. That interface allows you to build an action set. You can build your own action. You can build and deploy whatever you want to, and anyone can use that action. They don't need to know anything other than what's the interface to that action. This action allows you to maybe pull together multiple actions into one super action that does many things for you. This way you don't have to give the code to people. It's automatically available. In ProcCAS, we made it very similar to DataStep. We can't say it's identical because we needed so much more functionality. So it's similar. When you look at the interface, it's similar. That's all we can say. But it is integrated into our output delivery system. That gives you the ability to really produce elegant reports. ODS is very, very powerful, and it is pretty much what all the procs use to display their output. But the main purpose of CASL, the main purpose of ProcCAS, is to submit an action and process the results. That's what we're going for, is to submit and process. Now here's an example of some CASL code. We'll see exactly what this all means in a few minutes. But generally, we're talking about giving a name of an action, giving some control options for that action, and then giving parameters. And the parameters are what we call a list of directories. Each directory has a list of things. One of these lists happens to be our car table, which has a name and a where clause. And those are what we're going to send to our action. Now the SCCASL runCasl action is very similar. It's that it is an action. So you execute the CASL code on the server environment. It returns a dictionary as its result, so you can determine what it is that you want to return. It is under your control. You can also provide an exit status exactly to tell me what actually happened, you are in full control of that exit status. You can also provide input arguments and macros. The server side does emulate the sysput and sysget operations that you will find on the SAS side of the world. Now, an example of runCasl is you specify the action set and the code, and give me the code as a character string. You specify whatever variables you want, and that's in the form of a dictionary. And then you specify the macros you want, and those are the form of a dictionary as well. Now, example programs of a CASL program. Here's an example of just running a simple summary operation. I'm going to save the results in a variable. I'm going to save the status in a variable, and then I'm going to specify what my table name is. Once that runs, I'm going to check that severity status. What was it? Did it run correctly or did it not run correctly? If it's 0, then we're good. If it's not 0, then I'm going to set an exit status to say, I'm sorry, this did not work. That exit status is all up to you. Whatever you want it to do, that's what you could put in there. Otherwise, if I got a 0 response, I'm going to send a response. And that response is going to take this, the argument is going to be a dictionary. I'm going to say table equals my sum.summary. That happens to be the result I want to send back. And that's what I will get back on the client side. Now, one of the things we want to make sure we understand is exactly what we're talking about here. This is a picture of our server. It's got workers. It's got the main controller that you log into, and then you got the session controller, which is created for you and you alone. That's who we talk to. We're talking to the session controller. We're giving it work to do, and that work gets spread across the workers as we execute actions. So, let's prepare some arguments for our actions. One of the things that CASL does very well, we want to be able to submit an action and give it the parameters it needs. Those are going to come in 2 forms. One form is an array. The other form is a dictionary. So let's take a look at what that means. Well, first we'll take a look at the environment arguments that we can specify. You've seen these before. I can say result equals and give it a variable name. So whenever my results come back, it will go into that variable as a dictionary. I can specify the name of my status. That too is a dictionary. I can specify the name of my session. Because in Product CAS, we can inherit multiple sessions from the SAS session itself. So when you use the CAS statement to create a session, that session can be specified so you can point an action to any particular session you want to. You can then also ask for it to be run asynchronously. That means CASL will come back immediately. We will submit the action for you. The action will remain, the results will remain on the server until you ask for them. So this allows you to submit code to multiple sessions and then monitor them within CASL itself. Or you may be able to submit actions and then leave the session and then come back later and retrieve your output. Now, arrays are very important. They are essentially part of dictionaries. If you've got a dictionary, you may have a dictionary that says, here's one of my options. But the option may actually be an array of values. So arrays can be referenced in one of 2 ways. You've got curly braces that create arrays, and you got brackets which dereference items within an array. Now, the arrays can be multi-dimensional if you'd like. We don't really care how many dimensions you have. And they are all referenced as indices as 1, 2, 3, 4. reference a 4-dimensional array. Indexes always start at 1. We don't have 0 as an index, so that really was a decision we made to be compatible with really what we thought people would use this system for. Now here's an example of some arrays. We have some character arrays where maybe you're specifying a set of variables. You got make, model, type, MSRP. You may have values, integers. You may have lists within lists. So I've got a list within a list within a list. I can have dictionaries within a list. So you can pretty much exchange any of these values with other values that are lists, dictionaries, doubles, strings. As you see, you can reference or create a dictionary with or narrate with just using the angle brackets equals. Now, the directory is a little bit different in that they have a key. So every value in the dictionary is referenced by the key. The location in this list doesn't matter. Its location is not guaranteed. So we generally compact dictionaries. Arrays can be sparse, but we do allow you to reference dictionaries through array indexes, but we don't guarantee what you will get. One of the nice things we allow is we can do over a dictionary, and we will traverse each item within that dictionary while in the loop. So you can loop on every item in the dictionary. Examples of dictionaries are cartables.name. Cartables.name, the dot operation is an indication of a directory. The dot is a special operator that is very, very important to CASL. If you just say CASL cartables.name, that says I've got a dictionary. And I'm going to set that value to car's help. I can set the where clause as well with that designation. Or if I wanted to, I could do it the way I did it before and just specify it with angle brackets, with the curly braces. Once again, we can look at what a table option is to our fetch option here. We're going to fetch a table, and we're going to specify our variables, and we're going to specify our sort by. And we'll see a little bit more about how we can deal with the results that come from this. Now, one of the things that we also want to do in CASL, we want to be able to process results. If we can process results, we can generate really nice output. We can generate really elegant reports. So what do you get back from an action? You get back results. The results is a dictionary of values. They could be integers, they could be doubles, they could be strings, they could be binary, they could be maybe an image, it could be an audio tape, it could be a video. So any of those are likely to come back. The most prevalent result you'll get back is an action table. We call it a result table. The result table is essentially what you would think it would be in relation to a data step. It is something that has rows, columns, data types. It's got formats, and they come essentially in a two-dimensional form. You've got rows from 1 to n, and then you've got columns that have names. Within CASL, you can reference a table as a two-dimensional array with the first array index being the row number and the second being the column. So you can reference an individual item within a table by saying row, comma, name of column. And if you want to say I know what row it is, you can put the number there. But once again, we generally suggest you put the name just to make sure you're not wrong. Now, one of the things that we want to look at is that results are returned in the form of a dictionary. We have to remember that. So if you do a summary operation, you're getting back a result table. That result table isn't your result. That result table is in a dictionary. You must pull it out in order to use it. That's one of the most prevalent mistakes people make, is trying to use a dictionary as an item, such as a result table. Now, each client represents these tables in whatever form they choose. In Python, you use a data table. You use Panda. In CAS, we essentially allow everything to be a two-dimensional array, and we allow you to see exactly what you got back. We don't process the information at all. We just present it to you in the form that it came. Now, there are two important functions here that can operate on result tables. One of the things that people like to do is create their own result tables from other result tables, or have their own data that they want to add rows to a table. They want to be able to create their own tables, maybe combine information from multiple tables into one table, and then they can use that table possibly as an argument to a function or to an action. Here's an example of creating a new table. I've got 4 labels, 4 columns. I have 4 data types, and then I'm going to supply 2 rows of data. So once this is done, I've got a result table of 2 rows. Now I'm going to add 2 more rows to that table, and then I'm going to print it. Now all I'm going to say is print. I don't tell it anything else, and what I get back is it's really nice output. I get output delivery system output. I get a nice graphical representation of the data. You'll see more about what ODS can do a little bit later on. But another thing that we do in CASL is a lot of processing through the expression parser. The expression parser allows you to take things and create new things. 2 of the operations that we have are the where clause and the compute clause. They're probably similar to terms you would see in SQL, but the where clause will take a table and will run a expression over every row of that table. Then it will keep whatever rows meet that criteria. It allows you to subset a table. Now you can do a compute operation and compute a new column, and that's pretty cool too. Let's see. Here's an example of a where clause. So my new car would essentially be cars where MSRP is greater than 30,000. Or I can compute a new column saying I've got row, I've got ratio, I've got MSRP divided by invoice. I want it to be best 5.3, and my new column value is going to be MSRP divided by invoice. Now we can do more than this. We can actually combine these two, and we can look at something like this. It's much more about taking the power of CASL and utilizing it. Here we're doing a where clause, and then the dot says do the next operation, which is a compute clause. And then you got the angle brackets that said subset 1 through 5, which says give me the first 5 rows. And then I want you to also subset the columns through these 4 columns. And when you get done, you have a table that's 5 rows and 4 columns. That's pretty cool. Now we're going to look a little more at the output delivery system, exactly what it can do for us. So it really is used by every proc. This is how SAS output is done. It's important to understand that it also understands by group operations. So you'll see the next example, I've got a proc CAS and I've got a GLM operation. I've got a by clause in here, so I'm going to get by groups. and I'm going to print 2 through 6. Well, I happen to know that 2 through 6 happens to be the first group. I'm going to look at the output, and it's pretty cool. I mean, it actually displays in a very nice form. It understands it's a by group. It tells me which by group it is. This is exactly the same output you would get from GLM. One of the other things we need to do is really allow you to format data. CASL does support all the standalone formats. We also allow you to create dynamic formats through dynamic format variables, and we provide the put operation. Let's take a look at that. So here's a put operation. You give it an expression, whatever expression you want, and a format. Next, you do a best format equals best 6.5. That means best format is now a variable within CASL that understands that he's a best 6.5. I can change that to any other thing I want to, anytime I want to. And then I can use it in a put statement. And I get my expected results. So best format could be anything, but in this particular case, it's best 6.5. One of the things we've learned so far, hopefully, is that CASL was a very powerful language, allowing you access to CAS. It is the premier way that SAS accesses CAS. The expression parser is very powerful. That's where you'll get all your power. To generate really good reports, you need to be able to process your data into a form that ODS can take. And that's going to be taking data and putting it into the form of a result table. But CASL itself really has two purposes. It wants to create your parameters, it wants to submit your actions, and then it wants to produce elegant reports. As I say, these reports will go through ODS. It is the same output you would expect from anywhere else. But I want you to remember that there are three products that we're dealing here with. We've got CAS, and it is on the client side. We have runCasl, which allows you to run your code on the server side, and then define action, which allows you to take that code and place an interface on top of it that dictates exactly what the interface is going to be and acts just like any other action you've ever seen. So I really want you to try CAS. I want you to try CAS. I want you to try CASL, runCasl, define CASL action. See how easy it can be to really interface with your server. But that's pretty much just the beginning. You know, CASL is a very powerful thing. You can read about it in the recommended reading here. I hope you've had a good time. I hope you've learned something. I hope that you'll have a good day and that maybe you will use CASL in the future. Thank you.